What has James Webb Telescope revealed about the distant galaxies? The James Webb Space Telescope has provided a window into eons past, capturing a new image that shows the oldest of the galaxies ever observed. Incredible new images from NASA's James Webb Space Telescope have given us the furthest and clearest view ever of deep space. Moreover, using its incredibly sensitive NIRCam instrument, the Infrared Space Observatory found a 13.5 billion-year-old galaxy only days after its science operations began. Now the Space Observatory is ready to provide us with some closer facts about these distant galaxies. So, let's talk about them. Welcome to Space World. In today's video, we are going to talk about what has James Webb revealed about the distant galaxies in space. So, if you want to know more about it, then stay with us until the end of the video. NASA built its state-of-the-art James Webb Space Telescope to peer into the distant universe and back towards the dawn of time. And it's already doing so spectacularly. In the 2 weeks since Webb's first science images and data became available for astronomers to work with, they have reported a flood of preliminary discoveries, including multiple contenders for what could be the most distant galaxy ever seen. So, Webb's images reveal a wealth of galaxies glimmering in the distant cosmos, appearing as they did just a few 100 million years after the Big Bang, 13.8 billion years ago. Moreover, the telescope's astonishingly sharp pictures have shattered astronomers' preconceptions about the early universe. We had in mind an idea of what galaxies at these distances would look like, and how much detail we'd be able to see. But I think the reality is just kind of blowing our mind, said Jehan Kartalepi, an astronomer at the Rochester Institute of Technology in New York. So astronomers are now discovering record-breaking distant galaxies by the dozen, while sifting through the treasure trove of data now being collected by the James Webb Space Telescope. Prior to the launch of the James Webb Space Telescope, the most distant confirmed galaxy known was GN-Z11, which astronomers saw as it was about 420 million years after the Big Bang, giving it what astronomers call a redshift of 11.6. Redshift describes how much the light coming from a galaxy has been stretched as the universe expands. The higher the redshift, the farther back in time we see a galaxy. In addition, just a week after the release of the first science images from JWST, astronomers were reporting the detection of galaxies at redshift 13, equating to about 300 million years after the Big Bang. Now, a new wave of scientific results is smashing past that record, with some astronomers reporting the detection of galaxies up to a redshift of 20. If true, then we are seeing these galaxies as they existed about 20 million years after the Big Bang. That's a big if. At this stage, none of these redshift values are confirmed. To confirm the distances of these galaxies will require spectroscopic analysis, which splits the light from an object into what scientists call a spectrum. That analysis will come later. Nevertheless, it seems clear that JWST is fully capable of detecting galaxies from this long-lost era. The galaxies have been detected using different techniques. Astronomers led by Hao Zhongyan of the University of Missouri-Columbia used the gravitational lens created by the galaxy cluster SMACS J0723 to detect 88 candidate galaxies beyond a redshift of 11, including a handful estimated to be at a redshift of 20. If validated, these galaxies would be by far the most distant ever detected. Because of cosmic expansion, today these galaxies would be over 35 billion light-years away from us. Apart from this, 2 other papers report finding high redshift galaxies in patches of the sky where JWST has simply taken deep exposures, without resorting to gravitational lensing. These images are part of the Cosmic Evolution Early Release Science (SEERS) survey, which consists of images of 10 different patches of sky by JWST's near-infrared camera, NIRCam. JWST's near-infrared spectrograph, NIRSpec, joins in observations of 6 of those patches, while the Space Telescope's mid-infrared instrument, MIRI, studies 4. One team of astronomers led by PhD student Callum Donnan of the University of Edinburgh found a candidate galaxy at a redshift of 16.7, which equates to just 250 million years after the Big Bang. The team also found 5 other galaxies with a redshift greater than 12, all of which exceed the redshift record set by JWST's predecessor and now colleague, the Hubble Space Telescope. Meanwhile, using the same observations from CEERS, another team led by Stephen Finkelstein of the University of Texas at Austin discovered a galaxy with a redshift of 14.3, placing it 280 million years after the Big Bang, which the researchers have named Maisie's Galaxy, after Finkelstein's daughter. The astronomers found that this galaxy may have also been seen by the Hubble Space Telescope, but not recognized at that time. If a closer look at the archived data does reveal the galaxy, then Maisie's galaxy must produce very strong ultraviolet light from a powerful burst of star formation for Hubble to have spotted it. Indeed, the distant galaxy candidates display evidence for strong ultraviolet light emissions, enough to possibly settle the debate as to what ionized the hydrogen gas in the universe, bringing an end to the so-called cosmic dark ages. Over the years, astronomers have suggested causes ranging from radiation from the first stars and galaxies to outflows of radiation from the first supermassive black holes. In their paper, Donnan's team calculate the galaxy ultraviolet luminosity function between redshifts of 8 and 15. This function is an average of the amount of ultraviolet light associated with galaxies at any particular epoch. The value is strongly tied to star formation, because the more hot young stars are being formed in a galaxy, the more ultraviolet light it emits. Donnan's team concluded that there is more than enough ultraviolet radiation being produced by the stars in these early galaxies to ionize the universe. Therefore, the plethora of high redshift galaxies being discovered can be considered cosmic babies. These galaxies span only 1,000 or so light years across and contain just tens of millions of stars. Modern galaxies can host hundreds of billions of stars. Astronomers estimate that the cosmic babies are less than 100 million years old, and possibly as young as 20 million years. Scientists haven't yet identified any of the first galaxies in the universe, which may lie at a redshift 25 or beyond. Still, the new detections represent generations of galaxies that followed closely after, and that scientists see in the early stages of development. Adding to this, the amount of ultraviolet light, coupled with the abundance of high redshift galaxies that it is finding so early in its mission, suggests that galaxies were plentiful in the earliest history of the universe. Contrary to some expectations, the rate of star formation might decline gradually the farther back in time we look, rather than there being a sharp drop-off beyond redshift 11. Should follow-up spectroscopy validate these redshifts, it means that our universe was already aglow with galaxies less than 300 million years after the Big Bang, Finkelstein's team wrote in their paper. Now that JWST has discovered these strong galaxy candidates at vast distances, the next questions are how much farther back in time JWST can see, and whether it will be enough to discover the very first galaxies that existed, perhaps just 100 million years after the Big Bang. Well, such a discovery would necessitate a large dose of luck, since it would rely on fortuitous gravitational lensing to bring primordial galaxies into view. In addition, the surprises from Webb continue even a little later in the universe's evolution. One study looked at Webb's observation of cosmic noon, the period approximately 3 billion years after the Big Bang. This is when star formation peaked in the universe and the most light was created. Ren Seuss, an astronomer at the University of California, Santa Cruz, compared Hubble images of galaxies at cosmic noon with Webb images of the same galaxies. At the infrared wavelengths detected by Webb, most of the massive galaxies looked much smaller than they did in Hubble images. It potentially changes our whole view of how galaxy size evolved over time, Seuss says. Hubble studies suggested that galaxies start out small and grow bigger over time. But the Webb findings hint that Hubble didn't have the whole picture, and so galactic evolution might be more complicated than scientists had anticipated. With Webb just at the beginning of a planned 20-plus years of work, astronomers know they have a lot of changes ahead. Right now, I find myself lying awake at 3 in the morning, Kirkpatrick says, wondering if everything I've ever done is wrong. So, the Webb is set to make huge discoveries about space, and it's already doing a remarkable job at it. And according to its creators, it's only the beginning. And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.